We got vacuum ready, give it a test. Very good. Camera's ready, I'm ready. Here we go. And hit it. Hey there, fellow maker. Welcome down to my shop. I'm Bill, and today we're making space helmet visors. Not just any space helmet visor, mind you. These are visors for Adam Savage's ACES spacesuit. This is the suit that he will be wearing at New York Comic-Con for his incognito costume. This particular helmet has two visors, a clear one that goes on the inside and then a shaded one that can rotate down over it, I presume to keep harmful sun radiation from obliterating the eyes of astronauts around the world. Adam had those visors 3D modeled and 3D printed and mailed to us along with a challenge. You see, normally when you vacuum form something like a visor, you have a solid buck, like this. This is the visor buck for our buddy Danquish's Snake Eyes helmet, and we just pulled hot plastic over this surface to make a hollow, transparent visor. Now, when Dan 3D modeled this, to be able to fit it into the helmet it would go for, he actually reduced the outer dimension of the master just a little bit to account for the added thickness that the plastic for the visor would have on top of that. That way the visor would fit perfectly into the helmet that he also 3D modeled. For this project, we wanted to get a similar effect, make sure our vacuum formed visor would fit perfectly into Adam's helmet, but the master that we had was exactly the dimensions that he wanted the final visors to turn out. So instead of having a positive buck that we pulled the plastic over, we decided to try and make a negative buck that we pulled the plastic down into. This will all make sense in just a couple minutes. But first, let's deal with those 3D prints. These were printed on an FDM printer, and I think they were done in a PLA plastic. They required quite a bit of cleanup to get them nice and smooth. Brittany started with some EpoxAcoat body filler. This is similar to Bondo. It was mixed up with the catalyst and then smeared over all of the surfaces on both visor prints. The EpoxAcoat filled in any of the print lines and any voids that were left in the surface. Once it was fully cured, Brittany rough sanded it all smooth with a palm sander. After that, the visors were primed and any remaining imperfections were filled with an air drying spot putty. This was allowed to dry, and then the entire visor surface was wet sanded smooth. Next, Brittany mixed up some XTC 3D epoxy and coated the inside of the prints. We wanted to make sure the prints were more rigid and have nice, smooth insides. When that XTC was fully cured, we covered the insides with masking tape. This was all in an attempt to make it easier to pull the eventual expanding foam out of this form later after we made the mold. Speaking of, we mixed up some of that expanding urethane foam and filled up the insides of the visor. This took quite a bit more layers, time, and foam than we originally estimated. We also decided to fill up some of that space with crumpled up aluminum foil. Finally, we built some cardboard walls to direct that foam into a manageable shape as it expanded. Once the expanding foam was fully cured, we removed the cardboard and tape. We also cut off the bottom face of the foam, creating a nice flat part for the visors to rest on. The foam was then shaped with a rasp and then hot glued down to a sheet of plastic. Any exposed foam was covered with more masking tape and all of the surfaces were slathered in wax, again hopefully to help remove the parts from the mold that we were about to make. Spoiler, it didn't help. I also sprayed the surface with mold release. This also did not help. I think a paste wax probably would have been a better option. To make our mold, we used a high temperature epoxy. The first layer was EpoxAcoat HT. It was mixed up and brushed all over the visors and the surface that they were attached to. This layer is meant to grab all of the details, so we took our time and made sure to apply it in a nice and even layer. After that EpoxAcoat had about an hour or two to cure, we mixed up the high temp EpoxAmite. This is for laminating and for applying fiberglass cloth. This was also brushed all over the surface, but when it was still wet, we laid down small pieces of fiberglass cloth. We added a total of 3 layers of that fiberglass, but I bet we probably could have done a couple more to make a much more durable mold. Subsequent layers were pigmented so we could see where we added our fiberglass and where we needed to add more. These high temperature epoxies recommend a post-curing in an oven, but we don't have an oven in our shop, so we built a cardboard box lined with aluminum foil and we ran our heat gun into it for a couple of hours. We made sure to keep an eye on our improvised oven, fire extinguisher in hand, to make sure it behaved. When the epoxy was fully cured, we could finally peel it off of our plastic sheet. The flange was broken and trimmed off, and we set about pulling all of the foam out of the mold. As I alluded to earlier, this did not go as easily as we had hoped. Eventually, we did get the master 3D prints out of the mold, but unfortunately, they were pretty much destroyed in the process. This is what we get for casting a rigid mold around a rigid master. For traditional molding and casting, you would use a flexible mold, but in this case, we needed to make that mold rigid for vacuum forming. The good news is that the mold survived. Brittany did a little more fiberglass work and cleanup on the molds to make them stronger and to improve the surface quality on the inside of the molds. While I'm working on that, I'd like to take a moment to thank our fantastic patrons. It's because of your support that we get to not only work in this incredible workshop on awesome projects, but you're helping support an entire team. We have 4 people on the Punished Props team. That means there are other people here who have to do all the jobs that I don't want to do.
Bill, why would you shred my paycheck? Just date it later.
It's not working!
Thank you again, patrons, so much. If you want some extra credit videos, we have blogs behind the scenes and early release for all of our project videos. Head on over to patreon.com/punishedprops and consider throwing us $1. It means a ton to us and our amazing team. Thanks, let's get back to the build. To do the actual vacuum forming, I needed to build a special platen to hook up our vacuum. I built a box out of plywood that has a hole in the top to fit the molds that we just made. I installed some T-nuts on the inside of the top of this box so that I could bolt the molds down to the box. I clamped the molds in place and I drilled through my holes in the box top so that there would be identical holes in the flange of our mold. Then the box was glued, clamped, and screwed together, creating an airtight container. A hole was drilled into the bottom and enlarged to fit the adapter for my vacuum. I also had to make a specially sized frame to hold the plastic. I used more angled aluminum to make this frame almost identical to the one I made for my small toaster oven vacuum former. This wouldn't fit properly onto my new big heat box, so I needed to make an adapter to hold it suspended over the heaters. This adapter was made from wood and covered in aluminum tape, and it fit perfectly on my new, slightly smaller frame. I added some foam weather stripping to the edges of the box to help seal the air, but it ended up falling off, so I went and covered the entire top face with EVA foam. Next, I glued some washers onto my molds to help spread out the load when bolting everything down. I also needed to add some air holes to the molds themselves. I plotted out these holes near the edge of the visor forms. These were all carefully drilled out so that the suction in the box would pull the plastic down into the mold. Just to be sure we had a really great air seal, Brittany filled the inner seams in this vacuum box with quick seal and let it dry overnight. Then the molds could be installed into the vacuum box and we could get to forming some visors. The vacuum form molds are made, it's time to melt some plastic. We hit a bit of a roadblock. The original idea was to form everything in acrylic plastic, so I got a bunch of acrylic. This is 1/8 inch thick acrylic that I use for these, and acrylic is pretty tricky to vacuum form. The thing is, it's got moisture in it, and when you heat it up a lot, it tends to form bubbles right in the plastic. There is a way to solve that. If you have an oven in your shop, or even better, a vacuum oven, you can bake the acrylic overnight usually, or up to 24 hours to get rid of all that moisture. Unfortunately, I don't have any equipment like that in my shop, not yet anyway, but I still gave it a shot, and here's how it went. For the most part, it was hard to get the acrylic hot enough to form all the way down into the cavity. From what I read, the range was between 290 and 320 Fahrenheit as far as the surface temperature. I had to get it over 400 to get it to form all the way down into the cavity. And a couple things happened. One, the plastic got very thin in the middle. And two, when I did get it hot enough to form all the way in, that's when bubbles showed up. This is my acrylic and it's not going to work. So we're going with a different option. Is PETG. This is 0.08 inches thick, I think. And I got a whole sheet of it so that I can give it a try. Now I've done plenty of PETG vacuum forming in the past and I think this should work out okay. I'm just gonna have to tint the visors. See, the visors for this space helmet come in a pair, one clear and one smoked. So I'm gonna vacuum form all of them in this clear PETG and then the smoked ones will tint like we've done in the past. So let's get this open and get to forming. And there. Ta-da! Looks good. I can cut it out. There we go. And then cut through the protective sheeting. Cool. So I'm gonna need a bunch more of these, but before I do that, I'll show you how we put it in the frame. For this particular vacuum form pattern, I made a new frame that's exactly the right size, and it's 2 pieces, so it can accommodate a range of thicknesses. This plastic has a protective sheet on both sides. Some people will leave that on, some people will take it off. For this first one, I'm gonna take it off. We'll see how it goes. That goes on the frame. Top of the frame goes on. Ready? Not even close. To hold this frame together, I'm just using binder clips. And I found that you want to make sure these clips reach all the way in as far as they can go. Some of these are a little small and they do help, but you really want them to reach as far in as you can. These big ones are great. Our plastic is secured. Try and make sure there's no dust on it. Looks pretty good. Now we can go over to the heater. The frame can go right in. It fits nice and snug, no heat gets out, and we're ready to do our vacuum forming. The last thing we want to do before we do our forming is to use some baby powder on our mold. And this is a mold or a pattern or a vacuum forming buck. Those terms all get used. I'm just using a brush to make sure that the entire surface is covered in baby powder so that the hot plastic does not stick. And I'm just gonna vacuum up the extra. My heaters have a remote, so I'm just gonna lean down and hit it and turn them on. There we go. All 4 of them are going. I have my thermometer here so I can monitor how hot it gets. We're at 100 now, I just turned it on. We're wanting to get it over 300 degrees, but the PETG should sag quite a lot. And once it's sagged a bunch, we'll know it's time to get moving. We're about 8 minutes in, we're coming up on 300 degrees. I just want to show you how much the plastic sags. You see that? That's pretty great. It's starting to get a lot more pliable. We're gonna let it heat up quite a bit more. We're at 286. 290. We want to get well over 300 and then we'll give it a shot. We've been heating it for about 10 minutes. We're at around 300 degrees. It's bowing down quite a lot, so we're going to give it a try. Here we go. And hit it. Well, that was satisfying. Yeah! Everything's still kind of hot. The plastic's down to about 100 degrees, so it's not going to deform anymore. I can start taking the frame off. Got my gloves on. This frame is still very hot. That can come off, so. And then hopefully this will come out. Ta-da! That's fine. It's a little thin in the middle, but the pull looks really good. That looks pretty fantastic. The first pull we did, I laid it down and just let the vacuum pull it in. Now this is deforming the flat sheet a lot, and the middle ends up getting stretched quite a bit. You can see it's kind of thin in the middle. So what I've tried to do is to push the sides of the plastic down a little bit before we turn on the vacuum to get a little more material down into the mold, which worked. This I did, and it's quite a bit stiffer in the middle. However, if you push your fingers too far, you can leave finger imprints. So you can see I pushed the material in, but then that got stretched into the final part. So that's what we want to avoid. I'm still going to push material in, but I'm just going to be a little bit less aggressive about it. And go. This EVA foam is acting as a seal, and it looks like it's holding up really well. The foam seal strip that I used was no good. That came right out. That looks pretty great. Our visors are all pulled and I'm ready to trim them. We only need this dome area up here. Everything else needs to get trimmed away. So I put some masking tape on here along the seam to protect the visor while I cut it out. And then I just drew a line where the cut needs to be. I'm actually gonna cut a little bit beyond it, and then I'll go back in with the sanding tool to come back on that line. But for now, I'm just gonna rough cut it. And for that, I'm using my rotary tool. So this is a cutoff wheel in my rotary tool. This one is like a fiberglass one, so it's pretty durable. It's probably not going to snap off like the cheap ones that come with your kit. With the PETG, this kind of almost melts its way through, which is kind of what we want. With acrylic, it tends to shatter a little bit more, so I'm excited that we're using PETG. But I'm still going to wear this face shield while I'm cutting it out, because it's going to fling hot bits of plastic at my face. Ta-da! Ta-da! We put our bucket on our heater and we filled it with hot water and then heated it up. Now this did take a few hours to get up to the 140 degrees Fahrenheit that we wanted it, but it should be there. We will check the water and we are at 144 degrees, which is about as high as we want to go. The next thing we can do is add our tint. This is synthetic fabric dye. We want to use this black tint on half of the visors that we did. And since the PETG does not come pre-smoked, we have to tint it. So this is going to get mixed in with our hot water. There are a couple of things in this container. This is the dye, and this packet just goes right in, like that. And that will dissolve, the whole packet dissolves. Then this is the color intensifier, and this is a goo, so that goes in there. Everything then gets mixed together. Now this is a lot of water. This is like 15 gallons of water. So we're gonna need more than just one packet. For this one, we're gonna do 4 packets and see how that works. Bloop, bloop, bloop. Squirt, squirt, squirt. And then we stir. So there's 4 packets in there. We're gonna stir them until they're all dissolved. Before I put my visor in there, I'm actually gonna turn the burner off under there. I'm gonna just unplug it. I don't want there to be a hot spot right on the bottom because the visor is gonna be very close to that. So we're gonna let it basically chill while we do our dyeing. I've built this wire contraption to hold our visor suspended right in there. It's held on with these clips so I can swap it out for a different visor if I want to. And you can see I left a little bit of flash on the edge of our piece here so I have something to grip onto, and then the entire visor portion will be dyed nice and evenly. I also have a bucket full of cold water ready to go so that once this goes in the dye for about 5 minutes, I can pull it out and chill it in that cold water. The last thing I want to do before this gets dunked in our dye is to clean it with a little bit of rubbing alcohol. Got my gloves on, I've got a paper towel, and I'm just gonna clean off all of the surfaces that we want to get dyed with some rubbing alcohol to make sure there aren't any residues on there that'll have a bad effect on the dyeing. Into the bath we go. And my wire should hold it just under the surface, and then hit my timer, wait for 5 minutes. There's a T-Rex nearby. Now it's time to take it out and see how it looks. While we are rinsing the visor, I can plug the heater back in and let the water get back up to temperature before we go in for another dunk. I'm going to take it off of the clips for now so that it'll fit in our bucket of cold water. I can actually do that. There we go. So that is one round of dyeing. You can see compared to this clear one, it's quite a bit darker, but we want to go a little darker. So we can set this back up and let it go in the hot tub for another 5 minutes. Back in you go. It's been 5 more minutes. Let's take it out and see how it looks. Definitely darker. Let's rinse it off, cool it off. Oh, that's looking pretty nice. I think maybe one more bath will do it. 5 more minutes. Let's see how it looks. It looks pretty good. So that is tinted with 3 5-minute rounds in the bath, and that is normal. That is clear. So that is significantly darker. I can still see out just fine, but I bet you can't even see my face. So I wiped off all the water, let it dry, and now the last step before these can be installed in their helmets is just to give them a little bit of a polish. I've got this plastic polish. This stuff is designed for headlights, but it works great on something like this. I'll just take a little bit and then apply a nice coat to the entire surface in circular motion. I'll just polish an area for a few seconds. And it's got a little bit of a cloudiness there, and then I can go back in with a drier paper towel and buff the rest of it off. And what we're left with is a really nice smooth surface. Of course, I'll want to do the same thing on the inside surface as well. Make sure both sides are nice and shiny. The final step on these would be to trim off the rest of this and sand it down with a rotary tool so that it's nice and perfect for the helmet it's going in, but I don't have the helmets here. These are going to get mailed off to Adam and installed in his helmets. And hopefully there's a video for that, so you can go check that out right now. Hey, thanks so much for checking out the video. Hopefully you learned a little bit. This was a challenging build. We've never done this kind of vacuum forming before. Pretty happy with how it turned out. Hopefully, so is our favorite Mythbuster. As always, the tools and materials we use for this build will be linked down below. Of course, we have another video on tinting. If you want to learn more about that, you can check that out. We also have a video we just recently put out about that vacuum form table you saw us using. So if you want to learn more about those, head on over to our website and check them out. If you have any questions about this build, please let me know in the comments down below. And I'd like to thank our patrons again for supporting us and helping us make all these wonderful videos. That's everything I've got for you from the shop today. Thank you again so much for hanging out with me today, and I will see you in the next build.